Um, I think everyone knows Tim Orr. He's been around for a while, and he graciously volunteered to give a program on basic look at what longitude is, problems caused by not being able to measure it, and finally how it was measured accurately. And I know this is a topic of interest among people I know, and it's always good to have Tim participate as always. So I'm going to turn it over to Tim.
All righty. If we are ready to start.
Recording in progress.
Okay. Do let me know if there's any technical difficulties during the presentation so that I'm able to do something about it. I term this presentation Longitude for Beginners. I am not an expert on longitude. I am not an expert on chronometry or astronomy, or for that matter, any other thing. And what I did was what I think a lot of us did was we looked at this whole thing of longitude and said, what's this all about? And tried to bring ourselves up to speed. So what I learned first was that in the 18th century and before, there was what I would term uncertainty at sea. And that uncertainty was the result of ignorance, misfortune, and coincidence. So let's start in about 1739. Britain and Spain are at war again, as they have been over and over and over again over the entire previous century. This one was called the War of Jenkins' Ear because there was a sailor named Robert Jenkins who was engaged in a battle with a Spanish ship, and supposedly in the course of that battle lost an ear. So this is the context that we're in when this story takes place. Amongst other things, one of the things that the United Kingdom decided to do was to raid Spanish treasure ships in the Pacific Ocean. They were at war after all, and the Spanish treasure ships were carrying massive quantities of gold and silver from the so-called New World. But the question for them was, how are we going to get there? You know, you're starting up at United Kingdom and you're trying to get to the Pacific, but there is no Panama Canal in those days. So what they had to do was they had to do essentially what Magellan had done, and that is go by way of the Atlantic all the way down to the bottom of South America and through the Straits of Magellan to get to the Pacific. So there was this Captain George Anson, who was a Commodore rank, and he had 6 ships. He gets a very late start, unfortunately. So by the time he gets to the Straits of Magellan, it is the middle of winter. So here's a close-up of the map showing the general area of where the Straits of Magellan are. And there's up here, right where my arrow is right now, is essentially the entrance to the Straits of Magellan. And here is what that place looks like today. It's still kind of a desert, not much in the way of greenery, Today, of course, we see a lighthouse and a bunch of other stuff. But in those days, in 1740, there was probably next to nothing here. And so this is the entrance to the Straits of Magellan. And it was called by the British, using Spanish language, it was called Punta Dungeness, or Dungeness Point, because it resembled Dungeness Point on the coast of Kent in England. So there's the point in England, and that's how they got the name for this thing. So the idea is, what you do is you start at Punta Dungeness and you thread your way through to the Pacific Ocean. And a couple of things to remember. These countries, nowadays Chile and Argentina, these are both Spanish possessions. So Britain was at war with these countries. So what that meant was that when they got there, there was no possible way that they could put ashore for supplies or water or anything like that. They couldn't replenish their food stocks. They had to sort of sneak through the straits and hope that the Spanish fleet didn't catch them at it. It's winter, as I said. The weather is extremely bad. The weather is never good in the Straits of Magellan, but here they have snow, hurricane force winds, thunderstorms, rain, ice storms, fog, high seas, strong currents, and so on. So they make this journey through the straits, and it takes them 6 weeks. They're working and working and working for 6 weeks, putting up with all this horrible weather. 2 of the ships had to give up and return home. So that left them with just 4 ships. And then 1 ship was sunk. And that leaves them now with just 3 ships. And finally, the weather clears enough that they figure that they're probably through the straits and maybe a few hundred miles west. So what they would want to do at this point is they want to sail north to get into the main part of the Pacific and start plundering Spanish treasure ships. So they turn north, and unfortunately for them, almost instantly, they make landfall. And this is what they find. They find Punta Dungeness. In other words, they've been sailing for 6 weeks, trying to get through the Straits of Magellan, enduring horrible, horrible weather, and they suddenly discover that they're right back where they started from. Things are really bad for the fleet. They have lost 3 ships. They're low on food and low on fresh water. They cannot put ashore because it's Spanish territory. And now they've got to go through the whole process all over again. But worst of all, they're suffering a epidemic of scurvy on board the remaining ships. So they make their way through the strait again. And again, they encounter horrific weather. But finally, they do actually end up getting through to the Pacific. So it brings me to what I refer to as uncertainty at sea number 1. And the uncertainty was longitude. There was no way to calculate longitude accurately. What you did was you estimated your speed by dragging a log, actually a wooden chip type thing, counting the number of knots in a rope that passed through your fingers as this log went away from you, and you timed it for 30 seconds with a sandglass. And that was a way you used to estimate your speed and to try to figure out what was going on with your, how much sea you were able to cover. You also had to estimate direction by using your compass. And this had its own set of problems because this chart shows you compass deviation from true north. In other words, a compass does not show you true north in very many places on the earth. There's usually some deviation. And down there at the Straits of Magellan, there was easily something on the order of 12 to 14 degrees of error in the compass as a result of magnetic deviation. So they lost track of where they were, obviously, because they ended up back where they started. And the only thing that they're able to figure out fairly well is latitude. And there's a reason for that. Latitude is fairly easily measured. You use a sextant and you sight one of the pole stars. Now, up in the northern hemisphere, you would sight Polaris, or the so-called North Star, but you can't do that when you're south of the equator. So what you use south of the equator is something called sigma octantis, which is pretty close to true south, as you can see from the diagram. And you use the Southern Cross and the Southern Pointers to get you in the right area of the sky so that you can find sigma octantis. And so what was done for most of these voyages up to this time is, because latitude was pretty easy, what you did was you would figure out what the latitude was of the destination you were headed for, and you would get to that latitude and then try to sail east or west to get there. So in other words, you knew fairly well what your latitude was. You knew that the destination was on a certain latitude. So you said, okay, it's got to be either east or west of where I am. You would try to sail, staying on that latitude line and getting to that destination. So this is what Commodore Anson was going to try to do. So where were they going? Well, that's the problem. And their uncertainty number two was the fact that they were plagued with a horrendous outbreak of scurvy. It is a very rare disease today, but it was unknown then as far as what to do about it. Anson had lost 626 of his original 961 crew, and he was very worried that he would not have enough men to sail his ships for the remainder of the time that they'd be in the Pacific. Nobody knew at that time the cause of scurvy, but they had some sort of empirical knowledge, and they knew that if they put ashore for food and water, they knew that somehow or other, when they did that, the people who had the scurvy seemed to get better. They didn't know why, but they knew that the recovery was quick, and that is the best way in those days to cure scurvy. Unfortunately, of course, they're near Spanish territory, so they can't do that. So they're stuck on their ships. So what's their destination? Well, their destination is an island called Juan Fernandez. And this is about 300 miles west of Chile. And it's about 1,500 miles north of the Straits of Magellan that they've just come through. The good thing about Juan Fernandez is that it has no alliance with Spain at all. And in fact, it's sort of a freebooter type place where if you show up with money, they're happy to have you. They don't care what country you're from originally or who you're at war with. So that's where they're trying to get, is to Juan Fernandez. There's an opportunity there to get all kinds of supplies that they need, food and water and other supplies. And that, of course, is going to be the cure, they hope, for the men who have scurvy. So they sail north. Their idea is to sail north to 33 degrees south latitude, which they can do, as I said, because they can sight the pole star at night, and it's very easy to do. So the idea is get up to 33 degrees south latitude, and then what? Then what? Well, I put a map pin here at 33 degrees south latitude. And so they know that Juan Fernandez is on this line, but which way? Do we go to the east or do we go to the west? And so it turns out that what they decided to do is they guessed, that is, Anson guessed, that he was east of Juan Fernandez and had to sail westward. So that's what he does. And he sails for 3 solid days on latitude 33, and he sails west, and he sights nothing, just open sea, nothing at all there. And so he thinks to himself, as you would, oh my God, what if I'm west? What if I'm already west of Juan Fernandez? I've been sailing away from it, not toward it. So the decision is made. Let's turn back and hope that we will hit Juan Fernandez if we turn back. So this is what they do. They turn back east, and in approximately 4 days of sailing, they sight the coast of Chile, which of course is a hostile place they cannot go. But they now know that they missed it. They hadn't gone far enough west. And in fact, when they figured it all out, if they had just sailed a few hours more, they probably would have brought landfall in Juan Fernandez. So they have to turn around and head west again. And in the process, they lose 70 more of their men to scurvy. So the situation is becoming really dire. Eventually, they get to Juan Fernandez, and they are able to resupply and get their men recovered. But the problem is that they've really been hurt by this whole thing. And they've really been hurt by the fact that they didn't know what their longitude was. They didn't know it, and that messed them up as they were trying to go through the Straits of Magellan. And they didn't know it when they were up at latitude 33, and that caused them to waste well over 11 days trying to get to Juan Fernandez. So anyway, once they get there and get everything straightened out, they're in a position to be able to begin their mission of plundering Spanish ships in the Pacific Ocean. This is a model made much later of the Centurion, which was Anson's flagship. And this was built in about 1732. So the ship was only about 8 years old when they went through this journey. They did, in fact, capture many, many millions in gold, doubloons, and other treasure. And it was considered a highly, highly successful plundering trip. So that brings me to the some other uncertainties. How to find longitude? How are you going to do it? And that was a huge problem for this voyage and many others. The second is what to do about scurvy. So let's take scurvy first. Scurvy, there was no effective cure. There was no effective prevention of it until almost 1795, which was about half a century after Anson made this trip. So nobody knew what to do. Turns out that the thing that was the most effective cure for scurvy was citrus fruit, other kinds of fresh fruit, sauerkraut even turned out to be an effective cure for scurvy. And we eventually, of course, later on, medical science showed that the reason for scurvy was a vitamin C deficiency, and that's why these various things worked to get it cured. The other uncertainty, of course, is longitude. And in 1714, the British Parliament had established a thing called the Longitude Prize. And essentially it said, we will give 20,000 pounds in those days to anyone who can create a method that's reliable and that can predict longitude within plus or minus half a minute of longitude. So, longitude is in degrees, but each degree is measured in 60 minutes. And so they were looking at about plus or minus half a minute accuracy. Some people came up with purely astronomical methods. They were both mathematically and astronomically difficult. If you've seen the British production of Longitude, there's a scene in which this mathematician is trying to figure out longitude using pure mathematics and sightings of astronomical objects, and he screws up his math and he flies into a rage. But the other thing that was true about it was that it took a lot of time. And that was an interesting issue because he said, you've got to do all these calculations and they take you so long to do that by the time you finally figure out the answer, you're no longer where you thought you were. So time became the practical answer. How do we measure time? And the question became, how do we know the time in two different places on Earth at the same moment? And by the way, I mentioned up above there, the 20,000 pounds that Parliament was offering was the equivalent of about $12 million today. So there were a lot of people trying to work on this. So here are the basics. The Earth rotates once every 24 hours. So we say that the Earth passes through 360 degrees of longitude every 24 hours. And if we make the math calculation, we see that every 15 degrees of longitude is equivalent to 1 hour of time. And 1 degree is equivalent to 4 minutes of time. So this is something that we did know and that we could use to make our calculations. So we call Greenwich the prime meridian. It is the reference point, the starting point, the 0 degree point. We could pick any place we wanted. But of course, because it was Britain who was doing this, they picked the Royal Observatory at Greenwich, which is outside of London. And they said, that's going to be what we're going to call 0. So as it happens, if it is noon where we are and 1 p.m. in Greenwich, we are 15 degrees west of Greenwich. So we use the convention that west of Greenwich is minus and east of Greenwich is plus. So if we know the time at Greenwich and the time where we are, we can figure out the longitude. So how do we know the time where we are? Well, we use a sextant and we use astronomical tables. I'm not going to go into this. There's a lot of math involved, but it's relatively simple math, mostly addition and subtraction. And taking a measurement with a sextant on a rocking boat at sea is not the easiest thing to do. And it's complicated by all sorts of other things, like whether or not you've got cloudy skies or clear skies, etc. But the idea is that what you do is you use your sextant and you use your astronomical tables that you've brought with you as an extraordinarily accurate sundial. That's really what it comes down to. Your sextant and astronomical tables allow you to figure out what time it is, where you are, by taking observations. So how do we know the time someplace else? That's the issue. And we need some sort of chronometer. And so a lot of different things were tried. Believe it or not, there was a thing called the dog chronometer. And if you can imagine this, there was a guy who said that he had a pair of puppies that were brothers. And he claimed that if he stabbed one of the dogs with a knife, the other dog would howl. And so he literally proposed this solution that they would keep one dog in London and put the other dog on board ship. And then each day at noon, he would stab the dog in London, and the dog at sea, wherever it was, would howl, and the ship would know that it was noon in Greenwich. Well, of course, first of all, this didn't work when it was put to the test. And the second thing was nobody could imagine how you would do this. You'd have to have thousands and thousands of dogs penned up at Greenwich and stab them all at noon. And it was just a silly idea. The other idea was what was called the moons of Jupiter. There were, well, as we know, there are at least 12 moons of Jupiter. And astronomers knew that if you observed the position of 3 of the moons at night with respect to each other, that became a sort of a primitive clock, and you could actually figure out what time it was by observing the positions of these moons. The trouble with it is that, again, you were plagued by the problem of, did you have a good ability to sight Jupiter at night? And then were you able to make accurate measurements of the positions of the moons? And again, it was intensely complicated and prone to all sorts of error. Later, of course, when we finally got things like radio, it became possible to pick up a time signal from a radio station like WWV in this country or CHU in Canada and others, and get the time that way. But of course, radio was at least 200 years off from these guys, so they weren't going to be able to do it with radio. So how are we going to know what time it is in Greenwich? And that is the job that John Harrison solved. John Harrison was a cabinet maker originally and made a lot of his early clocks out of wood. And in fact, used a type of wood called lignum vitae, which is incredibly hard and incredibly heavy, but which is impregnated with its own sort of oil and didn't need lubrication. So anyway, he came up with some timekeepers that were resistant to temperature changes. Remember, I said, the guys going through the Strait of Magellan, they were plagued by ice storms and everything else. Plus, of course, when you get to certain other places at sea, the conditions can be tropical. So you needed to be able to compensate for temperature. You needed to be able to compensate for the motion of the ship. Ships rock and shift all the time, and Harrison's first chronometer, this one here, H1, was able to keep accurate time even on a ship that was rocking and moving about. And the other thing that Harrison's real genius, and partially from his work with the wooden clocks, was that he came up with the idea to resist wear, so that parts would be able to function day after day after day and not wear out. So Harrison creates several chronometers in hopes of winning the Longitude prize. H1, H2, and H3, they're referred to this way just to say Harrison 1, Harrison 2, Harrison 3. These first three chronometers required no lubrication whatsoever. H1, in fact, and the other two are still can be run today. And if you go to the Royal Observatory at Greenwich, you may very well see one or more of these running. And here we are, we're coming up on 300 years later, and they still don't need any lubrication. H1 on the far left there, unfortunately, was about, as I recall, about 5 feet tall and 5 feet wide and about 2 feet deep. So it wasn't really going to be convenient to have this thing on board ship. H2 and H3, much smaller, but still pretty large. Finally, Harrison came up with H4, which is like a giant pocket watch. Actually, probably about the size of chronometers that had been used in ships thereafter. It did, however, require oil, and so as a consequence, they do not run H4 today. I wanted to make a little point here about the difference between accuracy and precision. Most of the time, most of us, I think, throw around the term accuracy and precision as though they were the same thing. And at least as far as a chronometer maker is concerned, they're not. Accuracy is a measure of how far short do you fall of a known established standard. Precision, on the other hand, simply says, how good are you at hitting the same spot over and over and over and over again? So this is a chart from an American chronometer from about 1835. And what we can see is that this chronometer was gaining, on average, about 14 seconds a day. But in fact, it was very, very precise. In other words, it wasn't accurate. It was gaining 14 seconds a day, but it was very precise in as much as it was pretty much always 14 seconds. So what you do in a situation like that is you start with the last time that you checked the chronometer, that is when it was calibrated, and you say, how many days has it been since then? And you multiply that by, say, the 14 seconds average, and you say, okay, this is the deviation between exact Greenwich Mean Time and the time that the chronometer is showing. And you can do all this because your chronometer is precise, even if it's not accurate. And that's true to this day. In fact, I always say what I learned when I was doing analytical chemistry. If you have precision, if you can get the same result over and over and over and over again, you can get to accuracy. You can figure out what the accurate result is. But if you don't have precision, you're dead in the water. So here's another chronometer chart from the United States Navy. It's of a Ulysse Nardin chronometer, a Swiss chronometer. And what they're looking at here is temperature. And so I turned the thing on its side because it sort of makes it easier, I think. But what it shows is that you see those 3 red circles there. What it shows is that there's been a 40-degree shift in temperature, but the chronometer itself has varied less than 1 second per day. So that's pretty damn good. Here's another Ulysse Nardin chronometer, and we see something similar between 97 degrees and 40 degrees. It is about 1 second per day to 2 seconds per day. So not at all bad, given that there's been such a huge variation in temperature. This then is a chart that would be kept on board any ship of what the chronometer is doing. And that brings up another thing that I think is important. And that is that almost all ships carried multiple chronometers as insurance against damage, stopping, etc. In fact, one of the things that used to be said was you needed to have at least 3 chronometers on board ship. One to break down, one for someone to forget to wind, and one to tell you what time it was. And so it was not at all unusual for ships to go to sea with half a dozen chronometers all running on board, just because they were looking at insurance in case something happened. This was partially why it was possible for the mutineers on the Bounty to give Captain Bligh a chronometer to take on his longboat when they put him off. And he was able then to do the incredible feat of navigating back to England. So the question then is, how do we determine the time where we are? Well, the motion of the sun and the planets has been known precisely for centuries. Early on, people began keeping track of where the sun and the moon and all sorts of other things were at different times. And the motion of the planets and the sun is known very, very precisely. Noon is defined as when the sun is highest in the sky, which is to say when the shadows are shortest. You know, people say, oh, well, it's when the shadows disappear. No, that's not true. Whether or not the shadow disappears depends upon your latitude. But what you can say is that noon is when the shadow is at its shortest. So your sextant and astronomical tables become an incredibly accurate sundial, as I mentioned, and the math required is actually relatively simple. And that's important because you had people on board ship who were not trained mathematicians, and so they were not going to be able to do anything fancy, and they needed to have the ability to get a position without going to too much trouble. So how do we use the local time? Well, if it is noon in, say, Knoxville, and I picked Knoxville because it made the math close. I could have picked Nashville or Birmingham or Huntsville or, you know, Atlanta or something like that, one of the 5 cities of the Mid-South regional. So if it's noon in Knoxville, which you determine using a sextant and astronomical tables, it is 5:36 p.m. at Greenwich, which you determine by looking at your chronometer. And what that means, if there's 15 degrees of longitude per hour of time, Knoxville is 83.9 degrees west of London, or minus 83.9 degrees. So that's how you determine your longitude, is by comparing the time at Greenwich and the time where you are and making the mathematical calculation. So there's some coincidences that I mentioned at the very beginning, which I think are kind of telling. In 1736, HMS Centurion, which was Commodore Anson's flagship for this trip in 1740, carried H1, Harrison's first chronometer, on a test voyage to Lisbon in Portugal, and it performed better than the ship's navigator did over that trip. Not a very long trip, but nevertheless, the chronometer performed better than the navigator did. And coincidentally, of course, 4 years later, Anson goes to sea with the Centurion, but of course, no chronometer at that point because it hadn't been approved yet. So Anson died in 1762 after a long and highly successful career, and was buried at St. Michael and All Angels Church in Staffordshire. And it is mentioned on this plaque that he was famous for his voyage around the world, 1740 to 1744. So Anson was very, very well respected and liked by his men, in spite of all the trouble that they had. Something I want to recommend if you want to read something light. This is a book by Patrick O'Brien. Now, Patrick O'Brien, that's a pen name. That's not his real name, but he is the author of all of the Master and Commander series, which a lot of people have heard about, a lot of people love. There's a dozen or so books, and they are sea adventures and so on. Well, this is a very early work called The Golden Ocean. And it turns out that this particular book is about the trip of Commodore Anson and his fleet to the Pacific Ocean. And there's a lot of really interesting stuff in here. Patrick O'Brien is noted amongst seafaring people as getting the details very, very accurate. In other words, the story he makes up never actually happened, but the details that he puts into the story were oftentimes very, very accurate and historically correct. He mentions, for example, that there were quite a large number of men on board the Centurion who were all taking classes, literally taking classes in how to figure out longitude. And they were doing this because anybody who could become a navigator and do things like dead reckoning and figure latitude, longitude, and all that sort of thing, you got a higher pay grade for doing that. So there were lots and lots of people trying to learn how to become navigators on board ship. The other thing that I found fascinating is that the lower portion of the ship was filled with temporary walls. Most of the cannons you see sticking out there were only rolled into place when there was going to be a battle, and they actually had temporary walls that they put up to create cabins for officers. And so whenever that was necessary to go to battle stations, they'd have to tear the temporary walls out and move the cannons into place so that they could do battle. So it's a fun book, easy read. It's not technical or anything like that. And I think, you might find it interesting to do that. Of course, obviously, there are lots of other books available. Davis Sobel's book on longitude, and the book by Rupert Gould, who restored the Harrison chronometers, both of which are very, very popular, and so on. So I want to say thank you to a couple of people from chapter 160 in Boulder, Colorado, Dave Cooper and Tim Schultz. They supplied me with some of the chronometer rating sheets and data that showed up earlier in the presentation. The 1835 was a historical data sheet that was investigated by Dave Cooper, and the Elise Nardin sheets were from Tim Schultz, as was the chronometer log that was used on board ship. So that concludes this presentation, and I would be happy to try to answer questions if you have them.
So feel free to unmute yourself and ask questions, please.
This is Ken Penkel. Navigation that the U.S. Navy used during World War and World War II. Tim, do you have feel for that? And you know, I know the Hamilton chronometers that were used back then played an important part in navigation on the ships also. So can you give us a little history on that, Tim?
Well, sure. By the time we got to World War II, chronometry was a pretty mature science. Chronometers had been improved and improved and improved. Harrison was required, and it's kind of an interesting thing to me. He was required to submit his chronometers, like H4, to the Admiralty, and to allow them to completely disassemble the chronometer and look at it inside. He was in the situation where the Admiralty said, look, it's all very well that you managed to do this once, but we need to be able to be sure that we can manufacture these things in quantity and that they can be relied upon. And so there were all those things to overcome. So as a consequence, chronometry advanced and advanced and advanced. And by the time we got to World War II, yes, chronometry was a very solid science. And the Hamilton Model 21 was kind of the standard of the industry. And it was used on board ship. Now, Ken, I know you have a Model 22, which had a variety. It has a different kind of escapement, and it was available in a variety of different formats. In fact, one of which was a deck watch, what they call a deck watch. And so, you know, by the time you got to World War II, you had all kinds of chronometers. The fleets all over the world were using stuff of their own. The Russians had their own manufacturing and so on. So yeah, lots and lots and lots of chronometry going on. After World War II, we got into a situation where we had some new technologies which were available to us. As I mentioned before, you know, you could get radio time. So in other words, you could tune in your radio, find out what time it was in Greenwich. And for a long time, you know, that was a supplement to what your chronometer said, or a check on what your chronometer said. But eventually we got to the point where that was better than, or more reliable than, the chronometer was. And then of course we got into other things like LORAN, long range navigation, where they actually used little radio stations on land and on buoys, and you would bounce signals back and forth between the ship and the radio station, either on the buoy or on land, and get your location that way. There were a bunch of other radio-based things used for navigation as well. And then, of course, eventually we got to what we now call GPS. Although I gave a presentation to the Seattle area chapters a while back, and one of the fellows who was listening said, well, he had been in the Navy himself, and he said, believe it or not, he said, we still had to have, We had to have people on board. We had to have people who knew how to use GPS. We had to have people who knew how to use chronometers. We had to have people on board ship who knew how to do dead reckoning. And he said, because it's your fallback. He says, in other words, what do you do if the GPS doesn't work? Well, if the GPS doesn't work, you'd better have a functioning chronometer and a sextant and be able to take sightings. And if your skies are cloudy and you can't make a reading, your chronometer is useless. So now you better have dead reckoning. You better have somebody who's able to estimate direction, speed, and so on. So it's one of those kind of things where you have all these wonderful technologies, but you also have to have the more primitive technology. So you've got something to fall back on when the first one fails. And so it's been an evolution. You know, I would say chronometry is not much used anymore on a day-to-day basis, but it's still there as your backup when all else fails.
Other questions for Tim? Unmute yourself and go for it. Unmute yourself, Richard.
How about that?
Got it.
I've heard that the captain of the ship used quince marmalade to avoid the scurvy. Is that correct?
I've not heard that myself, but it's certainly possible and logical. As I said, the cure for scurvy turns out to be vitamin C, because the cause of scurvy is vitamin C deficiency. And virtually all fresh fruits, sauerkraut, all have plentiful vitamin C. And so, yeah, not at all impossible that marmalade would do the trick. I don't know. I've not heard that particular story. I mean, I thought it was kind of interesting to hear that sauerkraut proved to be an effective scurvy cure. And of course, the beauty of sauerkraut was that it keeps forever. You know, you could put a barrel full of it in the ship and it never goes bad. So, you know, but yeah, marmalade would probably work. I don't know how much you'd have to eat of it, but might be a lot.
Other questions? Certainly, I want to say thanks to Bob for recording this. And if
We lost your audio, Gary.
Yeah, Gary, you went mute partway through.
okay. Thanks to Bob for the recording.